All right, welcome to the Explainer. So we're all pretty used to AI that's, incredibly smart. But what if it could be provably 100% right? Not just a good guess, but a mathematical certainty. That's the huge idea we're digging into today. And believe it or not, it all starts with someone's really unique take on what it means to solve a problem.
And that's the mindset of Karina Hung. She's the 24-year-old founder and CEO of Axiom Math, a startup that's trying to, completely change how AI even thinks. For her, the best problems, the ones really worth solving, are the ones that involve, in her words, pain and suffering.
So let's break it down. Who exactly is Karina Hung, and what is she and her team at Axiom really building here?
Well, for starters, in September of 2025, her startup, Axiom Math, pulled in a staggering $64 million in seed funding. I mean, just to put that into perspective, that's more money than a lot of established companies raise in their entire existence. It's a massive, massive bet on a really audacious vision.
And you can kind of see why they're betting on her. Her academic track record is, frankly, just ridiculous. She finished a dual degree at MIT in only 3 years, then becomes a Rhodes Scholar at Oxford. After that, she gets into a super prestigious PhD in law program at Stanford, and then she drops out. So why would you do that? Well, she was following a piece of advice from AMD's CEO, Lisa Su: always run toward the hardest problems.
Okay, so that brings us to the core issue here. Let's really get into the fundamental problem that Axiom is trying to crack. What's wrong with the AI we already have? Why isn't it good enough for this kind of mission?
I mean, we've all seen it, right? We've been absolutely blown away by AI creating these incredible images or writing text that sounds just like a human. But here's the thing. At their core, these systems are just really, really good guessers. They're predicting the next word or the next pixel, based on trillions of patterns they've seen before. And that's exactly why you sometimes see those weird AI images with, like, a person who has 6 fingers on one hand. It looks plausible, but it's not right. That's a classic AI hallucination.
And this chart really lays out the huge difference in approach. You've got today's AI, the large language models, which basically learn from human feedback. But we humans are subjective, we can be wrong. Axiom's engine, totally different game. It's built on pure formal logic that can be mathematically proven as correct by a machine. No human opinion needed.
So, how in the world do you build an AI that literally can't be wrong? I mean, an AI that is just incapable of making a logical mistake. Well, the secret is in the language you teach it. You need a language that is so precise, so brutally unforgiving, that there's simply no room left for guesswork.
And that language is called Lean. The easiest way to think about it is like this. Lean is for math proofs what Python is for general coding. It's the special tool that lets you take these abstract mathematical concepts and write them down in a way that a computer can check with absolute rigor.
Yeah, and this is where the magic really happens. When you run Lean code, the compiler acts like this perfect, totally objective referee. There are no opinions, no kind of right, no gray areas at all. If the code runs, the proof is 100% correct. If it doesn't, it's wrong. End of story. It completely gets rid of guesswork and replaces it with cold, hard, logical certainty.
Now, this whole approach sounds pretty foolproof, right? But there's a huge catch, a massive challenge. It's kind of a classic chicken and egg problem. See, to train an AI to get good at writing in Lean, you need a ton of examples of Lean code for it to learn from. And the problem is, there just isn't very much of it out there.
And when I say not very much, the scale of this data gap is just mind-boggling. Look at this. For a language like Python, we have over 1 trillion tokens of code to train AI on. For Lean, we've got about 12 million. That is a massive difference. It's like trying to teach a kid to become a literary genius by only giving them a pamphlet instead of an entire library. It is a huge, huge hurdle to get over.
Okay, but let's be clear. This isn't just some abstract technical puzzle for computer scientists to worry about. The implications of solving this problem are enormous, and they're going to touch pretty much every part of our daily lives. So let's talk about how.
Think about it. Math is pretty much the language of the universe, right? It's the foundation for physics, finance, engineering, you name it. So an AI that can truly master formal math doesn't just get good at math, it gets a kind of superpower. It builds this core reasoning ability that can then be applied to almost any other complex field you can think of. And this is where it gets really practical for all of us. This tech isn't just about making things a little bit better. It's about making our world fundamentally safer and more reliable. We're talking about formally verifying that the software and hardware we depend on are bug-free. Think about discovering new, provable patterns in financial markets, or designing life-saving drugs faster. We could optimize the layout of computer chips and, this is a big one, prove that the planes we fly in or the bridges we drive over are absolutely mathematically safe. This is the bedrock for the next generation of technology. So just imagine a world where the software running airplanes or the medical devices in hospitals can be mathematically proven to have no critical flaws. That's the real takeaway here. This leads to a future where all those complex systems we rely on every single day are just fundamentally more trustworthy. It's about building a world with less risk and more certainty, literally from the code on up.
But look, making our current tech safer and better, that's really just step one. That's the beginning. The ultimate vision here is so much bigger. It's about creating an AI that doesn't just check our work, but one that can push beyond the known boundaries of human knowledge itself.
Yeah, the real endgame is to build a self-improving system, an AI that can autonomously discover new mathematical knowledge, not just verifying what humans come up with, but actually generating its own original ideas. An explorer in the vast world of mathematics, finding new theorems and concepts all by itself.
And it does this through this incredible self-improving loop. First, the conjecturer part of the AI dreams up a new mathematical idea, something unproven. Then, the prover part gets to work, trying to formally prove that idea using Lean. And here's the key. Whether it succeeds or fails, it learns from the attempt. It adds that experience to its knowledge base, getting smarter and smarter with every single cycle. It's like a self-taught genius that's creating its own curriculum and never ever stops learning. Just try to wrap your head around what that really means. This turns the AI into an engine for generating new knowledge, but at a speed and scale that no human could ever hope to match. We're talking about a system that could potentially solve mathematical problems that have stumped us for centuries, or discover entirely new branches of science. It's a true knowledge discovery machine. Which, of course, leaves us with a final, fascinating question about our own future. When an AI can discover new theorems all on its own, what's the role of the human mathematician? What's the role for any of us? You know, maybe our job changes. Maybe we shift from being the sole creators of knowledge to becoming collaborators, the ones who ask the right questions, who guide these powerful new AIs. It's a future that is incredibly exciting and honestly a little bit daunting. And it's probably coming a lot sooner than any of us think.